All right, 35, 36, and 37. Also, I'm going to say this. I'm going to have all these videos done, completed, out by tonight, by Friday before 11:59 p.m. So I have 65 more questions I have to answer. So that's maybe about, I don't know, 25 more videos, but I'm going to do it. Today is Friday, August 2nd, 2024. I'm going to do it. So wish me luck. Now, 35 to 37 is going to involve the fundamental counting principle. That's what we're going to see. Before I start the video, actually, I want to state what the fundamental counting principle is. So I don't want to use that color. Let's get rid of that. Basically, when it comes to the fundamental counting principle, you use this to find out the number of ways n sequences can occur. Number of ways n sequences can occur. And we can find that by looking at each individual event that makes up the sequence. So to find out the number of ways that n sequence will occur, we can multiply the number of outcomes for each event. M1 ways for event 1 times M2 ways for event 2 times M3 ways for event 3 times all the way up to M sub n ways for event n. And that lets us know the number of ways that n events can occur. So I'm going to move this picture down, actually. I want some more room. I'll move it back up if I need it. If I don't need the room. So let's do number 35. I'll do it over here. A restaurant offers a choice of 4 salads, 5 main courses, and 3 different desserts. How many possible 3-course meals are there? So, to find out the possible number of 3-course meals, we need to look at the items for our salads, the number of items for our main courses, and the number of items for dessert. There are 4 types of salads. There are 5 main courses, and then there are 3 desserts. So to find the number of possible 3-course meals, you multiply each of those cardinalities of those events. So 4 times 5 is 20. 20 times 3 is 60. So there's 60 possible meals. And that is your answer, 60 possible meals. So let's do 36. It says license plates are made up of 2 letters followed by 3 digits. How many plates can be made if repetition of letters and digits is allowed? I think I did this question already. Did I or did I not? Let's scroll back up. I feel like I had a question involved in this. Could be losing my mind. Could be deja vu. Okay, I'm sorry. That's actually from me taking one of the Math 108 exams, practicing it on my own. That's why I remember this type of question. So we have 3 letters followed by 3 digits. I'm going to use L for letters, D for digits. So L1, L2, D1, D2. Make my D2 a little bit further away. And D3. It says repetition of letters and digits are allowed. Keep that in mind. So, how many possibilities can I choose from for the first letter? there are 26 possibilities I can choose from for the first letter. Because I can repeat any option that I do choose, there are 26 available options for the second letter, 26 available options for the third letter. It says 2 letters followed by 3 digits. So there is not a third letter. There's only 2 letters. Look at me getting ahead of myself. For my digits, 0 through 9, there are 10 single digits. So there's 10 possibilities for my first digit, 10 possibilities for the second digit, 10 possibilities for the third digit. And because I want to find the number of license plates I can make, I can multiply these 5 quantities. You can also write this as 26 squared, because 26 times 26 is 26 squared. And 10 times 10 times 10, that is 10 cubed, or 10 to the third power. Either way, the answer will be 676,000 possible plates. I want to erase this down here, write a little bit better. 676 possible plates. Oops, so I guess we gotta move this down even further. Maybe I should paste this one at a time instead of in bulks. Number 37 is a 2-part question. You are to create a secret 4-digit code for your ATM card using digits 0 through 9. How many different codes can be made? Which is A. B. If you are only allowed to use the digit once, how many different codes can be made? So when I read 37A, 37A has no restrictions on the numbers, which means repetition is allowed. So I'm actually just going to remove this altogether. We can just put that back whenever we need to. So because repetition is allowed, and I have 4 digits, digit 1, digit 2, digit 3, digit 4, I have 10 possibilities I can choose from for each digit. So 10 possibilities for the first digit, 10 possibilities for the second, 10 possibilities for the third, 10 possibilities for the fourth. And because I want to find the number of possible passcodes I can make, or pins, I can multiply these numbers together. This also equals 10 to the 4th power, because that's 10 being multiplied 4 times. And that is 10,000 ways. That is 10,000 4-digit ATM codes. 4-digit ATM codes. Okay, 37B has a restriction. It says the following: if you're only allowed to use a digit once. Okay, so digit 1, digit 2, digit 3, digit 4, and also we can say that there's no repetition. You will not be repeating. Digit 1, you have 10 possibilities to choose from the first digit, so that's 10. For digit 2, because you cannot repeat any of the selected digits from the previous option, you only have 9 possibilities to choose from. For digit 3, you only have 8 possibilities to choose from because you already used 2 of the possibilities in digit 1 and digit 2. And for digit 4, you have 7 possibilities you can choose from in that case. So we can now multiply these numbers together. 10 times 9 times 8 times 7. And that's going to equal to 5,040 possible 4-digit ATM codes. I'm pretty sure that's correct. 9 times 8 is 72. Times 7 is 504. Times 10 is 5,040. And also, because there is an order to this, and each number is now distinct, that is a permutation. A permutation of 10 numbers. You're choosing 4. The numbers are now distinct, and the order matters. All right, that is it for our fundamental counting principle. Hopefully you understood how to compute questions 35 to 37. And I'll catch you in the next video. Take care.